So we're talking about derivatives. So the notation, right, if y equals f of x, y prime equals f prime of x is the derivative. There's another way I could say it as well, and that is I could say y equals f of x and put in the operator of taking the derivative, which is d dx. d dx is how I say it. d dx is the derivative operator. Like square root is an operator, right? Yeah. So this d dx, the top d, is what? What do you think? What word?
Derivative?
Yes, exactly. So I'm taking the derivative with respect to the variable x. d dx means derivative with respect to x, meaning x is your variable, right? And for now, that's all we're going to have is x is our variable. So here I get another version. I have d dx, dy dx, that's the result of this, right, equals d f of x dx, or y prime, or f prime of x. And you can see why we would rather use the other two, because they're easier to write. So anyway, what is this derivative? This derivative, so f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h, if the limit exists. And f prime of x is the derivative function. And what does it give? It gives me the slope of the tangent line at any point along the curve. Or on the graph of f of x, right? On the curve, same way. So we're kind of doing this in the problem where we find that replacement function in our limits, but most of the time we're finding just one point. This is going to allow us, right? This is we've been doing things so that it gives us the point, the slope at one point, right? Like in that homework problem we did today, number 2.1, number 5, it's going to give us the slope of the tangent line at 2, right? But we'd like to keep it general so that we could find the slope of the tangent line at any point, right? And so you'll see, like I'll change my my Desmos dynamic secant line to be a dynamic secant line and tangent line now. Once I have these derivatives, I can do that, right? Hey, Lucy. My dog just falling asleep during my lecture always. Okay, let's do a real quick example, okay? Now, I want to kind of teach you shortcuts at the same time I do this limit, okay? So I'm saying derivative shortcuts and long cuts. Derivative shortcuts and long cuts. We're going to memorize the shortcuts, and we're going to practice that limit, right? So I'll say to you on test, your chapter 2 test, I'll say find the derivative using a limit, right? So for example, if y equals x squared, we're going to show that y prime equals 2x. Who knew that already? Who knew the derivative of x squared is 2x? Nice. So the shortcut that you should have memorized here is that if y equals x to the n, y prime equals n times x to the n minus 1. Right? So this is my shortcut that I want to memorize or put on my formula sheet or both. And you can see that my original function is x squared, and then the shortcut is telling me take the power and move it out front as a coefficient, right? Take the power, move it out front as a coefficient, and reduce the power, right? Do you see that? So the power comes down out front and then gets reduced, right? Yes, you with me there? Good, let's show it using the limit, right? So I want the limit as h goes to 0 of f of x plus h minus f of x all over h. And in this particular case, it is x squared, right? So I'm going to do x plus h squared minus x squared all over h, right? You see that? Oh, and I still need my limit, right? So notice, right? I took my function x squared and put in x plus h inside of it. Now, I'm pretty much, when I have polynomials, I always do it this way, okay? So I could keep going and writing this the long way, but I prefer to go f of x plus h, okay? That is x plus h quantity squared. Okay, that's x plus h times itself, right? And then I start distributing. I get x squared plus hx plus another hx plus h squared. Don't let me go too fast here, right? I'm just doing that FOIL. And then I finally see I get x squared plus 2hx plus h squared. How is everybody there? Nice. And then underneath it, I'm going to write f of x, and I'm going to be very specific about where I put the f of x. I want to line up things that match. So f of x is x squared. I'm going to make sure it lines up with my x squared term, right? Because what am I going to do with them? What does this say to do? A difference. I'm going to subtract them, right? I'm going to subtract them. So the x squareds are going to go away. So I get f of x plus h minus f of x equals 2hx plus h squared. This green circle here is not just a difference, it's a what? Alan should know because I tortured him with it in pre-cal. It's not just a difference. We called it something else in pre-cal.
Difference quotient.
Difference quotient. So the difference is the numerator. The quotient is divide by h, right? So now I'm going to divide this by h. And I want to factor out an h here. And I can see an h cancels. And here's my difference quotient. What is this? This is the slope of the secant line, right? At some x and some h later, right? Right? At some x and some x plus h later, so some h later, right? So if I have an x and an h, I could figure out the slope of the secant. Here's the weird part in that homework in 2.1, number 5, h would have been 0.5. X still would have been 2, but h would have been 0.5, and then 0.1, and then 0.05, and then 0.01, right? So almost ready here. Here's my f prime of x. Is going to be the limit as h goes to 0 of 2x plus h. I'm going to plug in the h as 0, and there's my derivative.
And that
2x.
That part just above is just written as an expression. You're just putting the equals to show that you're continuing to write, right?
You're talking about this box?
The f. of x plus h minus f of x over h, and then you put equals. You're just writing that as an expression, basically.
Correct.
Okay. Yeah, that makes sense. Okay.
So there it is. There's my derivative, right? Now, this thing is kind of nice in that you can see it's a variable. So my derivative is variable, right? And think about it. When I get the slope at 0, of course it's 0. When I plug in 0 into 2x, I get 0. 2 times 0 is 0, right? If I get the slope at 1 and I plug in to the derivative there, I get 2 times 1, so the slope is 2. So the slope is changing anywhere along the curve, right? All right, let's do another derivative. Let's say f of x is 1 over x. I'm sorry, square root of x. Who knows the shortcut?
So it'd be like 0.5 to the negative 0.5, basically. Or negative 1.
I
had that wrong.
We need an x in there, right? 1 over 2 square roots of x is my derivative. This one is used also with that same shortcut, right? So f of x is x square root of x, which is x to the 1/2 power, right? Everyone should agree with that. So what's my shortcut say? Take the power down to the front as a coefficient and reduce the power by 1, right? Yes, you with me? So that's 1/2 times x to the minus 1/2. What's a negative exponent mean? It means reciprocal, and the half power is square root.
Yeah, that's what I was getting at in my head. I just verbally.
Yep. So there's my shortcut, right? There's my shortcut. So x to any power when I'm taking that derivative, except for x to the 1. That's the one we don't want to really think about. When it's x to the first power, right? Think about that. If it's y equals x, what's a derivative, by the way? What's a derivative?
The equation of the slope of the function.
Sure, just the slope. It gives me the slope, right? And what's the slope of this? What's the slope of y equals x?
Just equals the same as x. It's a linear function.
Yeah, no, but what's the slope?
Well, at what point?
Every point.
Yeah.
Yeah.
It's just x.
No.
Wait.
No.
The slope is 1.
Yes. And guess what the derivative of y equals x is?
It's 1.
Y prime is 1. Yep. So when it's linear, I just have to, right? I just find slope. Boring. It's the same slope everywhere. But when it's not linear, I'm going to get a variable slope. All right, so let's do this one. You ready? So f prime of x is be the limit as h goes to 0 of the square root of x plus h, right? I'm plugging in x plus h for the function. Subtract off the original function, divide by h. So when I have polynomial over polynomial, I work on things separately. But when I have a radical or I have fractions, I'm going to get that replacement function right away from this whole piece. Hey, everybody's here. 4, 8, 18, 20. Yes, everyone's here. Nice. So we want to find that replacement function, right? Square root of x plus h minus square root of x all over h. And what am I going to use? The conjugate square root of x plus h plus the square root of x all over itself. Is everybody okay here? Is everybody with me here? Again, my chat is open if you want to talk that way. Anybody need a moment? Anybody have questions?
Second.
So we're going to leave the downstairs alone because you can see we use the conjugate of the numerator, right? And so I'm going to get what? X plus h minus x all over h times the quantity of that conjugate, right? Don't let me lose anybody. Agree with this step?
And how come you picked the conjugate to get a solution here?
Because I saw radicals, right? That's what I already taught you with
Okay.
limits. If I see polynomials, factor. If I see fractions within fractions, LCD. If I see radicals, conjugate.
Okay.
Yeah.
All right. Those I'll. Yeah.
Yeah. Yep.
Because I had fractional notes on that, like, or partial notes on that, so it was like a little bit messed up in my head. Okay.
So I can see, right, my x's will cancel, and then my h's will cancel, and I finally got my replacement function. Notice that here I can't plug in h as 0, right, because I get 0 over 0, right? But once I cancel those h's, I can, and this is my replacement function, right, the one that I can take the limit of. So I'm ready to go back to my limit now. F prime of x is the limit as h goes to 0 of 1 over square root of x plus h plus square root of x, all of that in the denominator. And I'm ready to plug in. Since I'm plugging in, I'm at the wall. I don't need to keep saying you're getting closer and closer. I'm just going to plug in my 0 for h. And then I see I get 1 over rad x plus rad x on the denominator. And there's 2 of them, right? So there it is. F prime of x is 1 over 2 square roots of x. Let's do a quick dynamic tangent line with this one, right? But I don't want to go too fast here. Don't let me leave this page if you're still copying or still thinking.
Yeah, I'm copying.
Okay.
Professor, I was looking at the review, and it says you can use a shortcut. So do we use the shortcut and then prove it?
No. If I say you can use a shortcut, use the shortcut. If I say find the derivative using a limit, that's what I'm calling the long cut. and for all of you that know how to do the derivatives quickly, you know, I'm going to annoy the heck out of you for this first test, but so what? Just get over it, right? So when you're going to have to do a lot of these derivatives by hand, this long way with the limit. Okay, I'm going to do a quick dynamic tangent line.
Yep.
Dynamic secant line. Okay, all in one graph. So I'm going to use Desmos. What's going to happen when you create one of these derivatives? You're going to actually test it on your calculator during your test. So make sure you do that at least once. Meaning once you find your derivative, make sure that it gives you a tangent line somewhere. So I'll do that first, okay? So I know I've got the function, right? I know f of x is equal to the square root of x, right? Oops, equals Robert. And there it is. I want to pick a point on there, something in the domain. So for example, I can pick the point 4, comma 2, right? Square root of 4 is 2, right? We agree? So I'm going to get the tangent line at that point. Yes? Well, yes, everybody with me here? And if you're using, you can use Desmos while I'm doing it, right? There is a way to plot a point on your calculator, your TI 8384. Just do a quick Google search on it, right? But I want to look at what I know so far, right? For this, I know f of x is square root of x, right? I know f of 4 is 2, right? So I've got my picture so far, right? At 1 to 4, I've got a height of 2. I know that this tangent f prime of x is 1 over 2 square roots of x. That's in general, right? That's for any x. So I know that the slope of the tangent, that's a t. I don't need it. I know I'm doing a tangent line. Is f prime of 2. F prime of 4, right? So 1 over 2 square roots of 4. So what is that? 1/4? Everybody with me? So that I need a point. I need a curve. I need a point on the curve. Anything in the domain is fine when I'm double checking my derivative. And I need the slope. And then I have everything I need to get my tangent line, right? So my tangent line here is going to come from y minus 2 equals 1/4 all times x minus 4. Right? So y minus 2 equals 1/4 x minus 1. So y equals 1/4 x plus 1. Make sure someone double check me, please. Anybody get the same? Anybody get the same? No home yet? Nice. All right, so I'm ready to put this tangent line on my curve. Oops, sorry. And if I'm going too fast, just slow me down. My coffee, I just had 2 cups of coffee, so I feel like I'm flying. 1 divided by 4 times x plus 1. And there's my tangent line. Yeah. Victory. And it's nice here, you can really see that it hits at 1. It's clear it should be a positive slope, right? So you've got little graphical hints. You know, if you're a student that doesn't like graphing, you want to get over it, because you're going to be able to double check a lot of your work just by putting the graphs in, right? Or you're going to help yourself be able to get solutions by looking at graphs, okay? It's kind of nice if I make this one dynamic. So let me do that. Don't bother doing it. Try it on your own. But let me do another curve with a dynamic tangent line. Okay? So, and please, I'm your Uber driver. If I'm going too fast, slow me down. Don't wait till I drop you off and then give me a 0 rating, you know? Just like a cop following me all the way home and knocking on the door and then giving me 50 tickets for speeding. No, you still stop me when you first see me speeding. Give me 1 ticket, right?
Can you go back to the whiteboard for just a second?
Absolutely.
Okay, thank you.
Yes.
I guess I just okay.
Yeah, no problem. I'm Polish. I'm not Russian. So f of x, I'm going to do the dynamic, okay? So just watch. Don't try and do it with me. Square root of x. I'm going to put an arbitrary point in of a comma square root of a. Squirt. And you see I now have my slider a, right? And it doesn't make sense to go to negative 10. It's not in the domain, right? So a can go from 0 to 5, and we'll say by 0.2 or so. It doesn't matter, really. So you can see I can control that slider here, or I can control the slider on the actual curve, right? And I want to put the tangent line on there. So I know the slope is 1 over 2 square roots of x, right? My derivative, but I'm going to be putting in a, right? I'm going to be putting in that arbitrary x value. So I need y minus f of a, or it's square root of a, but I can keep it general, right? And I guess I should have, when I did my arbitrary point, it would have been better to me to do a comma f of a there, but it's fine. Y minus f of a equals 1 over 2 square roots of a all times x minus a. Right? You can see I'm doing the y minus y1 equals m times x minus x1, right? And then that's my dynamic tangent line. So what's the interesting point on here is, right? And so this thing is going to calculate my slope at any point. But what's the interesting point is, imagine I'm skiing down this hill, right? And the purple line is my skis, right? What's the interesting point? What happens to my skis right there? What happens to my skis right really close to the end there?
Goes up and up and up and up.
Yes. And what would we say about it?
Well, you could say at the point 0 that the slope is undefined.
There you go. Exactly. And it's positive or negative infinity. The best part is you think about me skiing, I did a face plant in the snow, right? My skis are sticking straight up in the air. And so look at my derivative though, right? Look at my derivative. What's my derivative? Where did I have it? Here it is. Here's my derivative, right? What happens when I plug in 0 to that derivative? I'm dividing by 0, right? Dividing by 0 is undefined. We really know it's plus or minus infinity.
You don't know if you're approaching from the right or
exactly.
the left.
It's so steep, but I don't know if it came this way or if it came that way. In this case, we do, right? We know which way I was coming down the hill, but it doesn't matter. It's straight. It's vertical. So the interesting thing is, when I have a vertical tangent, I'm going to have a 0 in my denominator of the derivative, or vice versa. If I have a 0 in the denominator of the derivative, there's a vertical tangent line. If there's a 0 in the numerator, it's a horizontal tangent line, right? How are we doing today? We okay?
Yeah, I'm okay.
Yeah. So what's nice is, and if you look at my chapter 2 review, there's a bunch of functions there where I ask you to find the derivatives using a limit. So any of those are fair game. And of course you can make up your own, right? You want to keep it to polynomials. Don't go higher than x squared. Don't go to x cubed. Don't go to x to the 4th for sure. X cubed is somewhat okay. X to the 4th is ridiculous.
Because then you gotta go back to the polynomial theorem.
Exactly.
You haven't taught us that yet.
Well, and I'm not going to, because we've done it in algebra 2, right? How to expand a polynomial. But let's do another one, okay? Let's do a real simple one. Let's say y equals 3x minus 2. Anyone tell me what y prime is?
Y equals 3.
Yep. Y prime is 3, right? The derivative at any point is 3. The slope at any point along this curve is 3, right? But let's show it with, here's our shortcut, right? Shortcut. is y equals mx plus b, implies y prime is m. So we got two shortcuts so far. This one and the other one, which is called a power rule. Bring down the power, reduce the power, right? All right, so here we go. F prime of x is the limit as h goes to 0 of 3 times x plus h minus 2 minus 3x minus 2. Be careful with your parentheses there, all over h. So I see my function evaluated at x plus h minus my function, careful of parentheses, all divided by h. Right? Everybody with me? Nice. So now I'm going to just expand. I'm going to simplify upstairs. Right? So I've got the limit as h goes to 0 of 3x plus 3h minus 2 minus 3x plus 2. And the trick here is, if you have non-h terms, they should go away. You should only have h terms left, meaning terms with a factor of h in them. So it's pretty clear that the 3x's go away and the 2's go away. So I'm looking now at the limit as h goes to 0 of 3h over h. Ha! Nice. That's the limit as h goes to 0 of 3, right? The h's cancel here, right? And what's that limit? What's the limit of 3? What's the height of 3 as h goes to 0?
0?
0. No, no.
Wait, oh.
What's the height of 3 at any point? 3.
3.
And there it is. F prime of x is 3.
So
yes, no.
When we come to replaceable when we replace our function as much as possible and h's are left, we just plug the zeros with h.
Exactly.
H with 0.
Exactly. Okay. And if you get a 0 over 0, still you're not at the replacement function, right? You're not quite at that replacement function yet. What do you think? Another one? So we did a polynomial, really easy one. Tried one a little bit more complicated. We did linear. We did a radical. Let's do a fraction, right? And don't let me go too fast, right? If I'm going to the next page and you're still working on that page, don't let me go too fast, right?
So the form for this rule is basically just you see yx plus or y equals mx plus b, and it's like, okay, Alan's linear function power rule.
No, I just know the slope, right? The power rule is when I have x to some power that's
okay.
not 1. Why don't I like the power rule here? Y equals x to the 1, right?
You get 0.
Well, yeah, so I get 1 times x to the 1 minus 1. And that's weird, okay? X to the 0 is weird. When is it weird? What x value? What x value am I weird? 0 to the 0, yes. 0 to the 0 is one of these indeterminate forms that we're going to talk about pretty soon with something called L'Hopital's rule. So 0 to the 0 is a little bit weird. We're not ready to talk about it. So we're just going to say, if I could see it's linear, I know the derivative is m, right? That's my shortcut. But again, we want to be able to do the limit. Nice. Let's do one more and then quit early for a Friday. For our first Friday together, right? The first Friday of this semester, I was at the dentist all the way to 2:30. I started at 8:30 and ended at 2:30.
That's rough.
No, 2:30.
Oh.
Let's do one more. Let's do a fraction, right? So f of x is 1 over x. Who's got my derivative right away? And don't worry if you're going, how the hell are they doing these derivatives? Could be a couple of things, right? Could be they're just geniuses. Could be that they had some calc in high school. It could be anything, right? So don't stress about it if you don't see the shortcuts right away. Who's got the shortcut anyway for me? Do you know this one by heart? So the answer is 1 over x squared. And I can show the shortcut with the power rule, right? So the power rule says this. If I have y equals x to the n, right, y prime is n times x to the n minus 1. That's my power rule. That's my shortcut rule that I'm either going to get the tattoo of, or better yet, put it on the formula sheet for the test, right? And then in our case, right, we have, I'll use y. Y equals 1 over x, which is x to the minus 1. Oh, I made a mistake, sorry. It's a negative 1 over x squared, sorry. So y prime is bring down the power, bring down the negative 1 as a coefficient, and then reduce my power by 1, right? So that's negative 1 times x to the negative 2. And so there it is, negative 1 over x squared. And you want that prime symbol to be that little slant guy, right? So y prime is negative 1 over x squared. Now what's interesting about this, if we look at the graph 1 over x, right? This is my graph 1 over x, right? Notice that any tangent line I draw, look at that tangent line. Look at this tangent line. What do you notice about the slopes of any tangent line I could draw? What kind of slope would they have? Positive or negative? Negative, exactly. And so this negative, right? The 1 over x squared is always a positive number, and that negative out front will always make it a negative. So the slope is always negative. What could you say about the function? Is it always doing something? Walk on that function from left to right. Which way are you walking? If I'm moving left to right on the function, which way am I walking in terms of heights?
Or
decreasing. I'm going down and down
going
and
down. Exactly. No matter what part of the function, if I'm walking left to right, the function's decreasing. And this is chapter 4 I'm talking about. It's called the first derivative test. You can tell I have no patience. Well, I'm not a doctor, so I have no patience. But I have no patience. I'm teaching you chapter 2 right now, but I'm already sneaking into chapter 3, and I just mentioned chapter 4. So I can't wait for you to see the whole thing. I hate the book is suspenseful, right? They won't tell you who did it. I'm going to tell you who did it, and then we. All right, let's do this one. Ready? This is our last problem today. We'll go have breakfast. We want f prime of x is the limit as h goes to 0 of 1 over x plus h minus 1 over x all divided by h. Now you see I'm doing a couple of different things. I'm writing the limit over and over, or I'm doing replacement functions. This one I'm going to do that replacement function. I want to start with that inside piece, right? And multiply by what over itself? Who's got the secret for me?
Yes, and common denominator.
Yes. Can you just give it to me? Can anyone give it to me?
X minus x plus h.
X times x plus h. Yep, over itself. Right? I'm just looking at those interior denominators. Right? And I'm multiplying them together. It's really a common denominator if you do that. But this one turns out to be the least common denominator. And I'm going to try and keep my colors straight here. Okay? I'm going to keep my original in purple. and I'm going to distribute in with red. So I can see that original in purple, and then my LCD distributed into every numerator, right? And I'm trying to take my time here. I'm Polish, I'm not Russian. I had a student last semester, and she said, "I'm Russian." I said, "I'm not. It's even funny if you're Russian. I'm Russian, but I'm not Russian."
So here, I thought we multiplied it with the opposite denominator, so x minus bracket x plus 8. That's right.
So no, I want LCDs, right? So I'm just looking at interior denominators, and I'm going to multiply them together. That's it. That's my LCD, and I'm going to make sure I multiply by 1. So I need the LCD over itself. Now some things cancel here, right? I can see my x plus h's cancel and my x's cancel. And I'm not in a rush here. I got x minus quantity x plus h all over hx times x plus h. Trying to take my time, right? Trying to do a baby step on each step. Tiny little thing that it's really clear when I look back on it that I can see, you know, I can see what I did. Try not to do too much in my head. It's dangerous. I can't grade it either. If you're doing stuff in your head and not on the paper, I can't grade it, right? Or it will hurt if I do grade it. So now I'm distributing. Again, and I'm just going real slow. I'm trying to be patient so that I don't make mistakes. My x's cancel. And it's a little bit annoying if you're really good at algebra to watch me do such a little step at a time, but just want to be safe. I want to make sure I don't make a mistake. So I got a negative 1 over x times x plus h. And there's my replacement function, right? How we doing? We okay?
Or can you scroll up a bit?
Mm-hmm. I have mad Zoom skills. So I'm ready to take my limit now, right? I know f prime of x is the limit as h goes to 0 of negative 1 over x times x plus h. And that is negative 1 over x times x plus 0. And you can see it's negative 1 over x squared. Boom, done. I didn't finish as early as I wanted, but I'm not going to do any more today. So I want you to have a great weekend, get some work done, get your homework done, start working on the Chapter 2 review, do those squeeze limit problems, start working on some derivatives, right? Send me questions if you have them. Okay?
All right.
Nice. See you on Monday. Nahom, if you don't want to stick around, that's fine.
Thank you, Professor.
You got it. Have a good weekend.
Thank you.
Thanks, Professor. Thanks, Professor.